Imagine that, right at this exact second, the sun simply blinks out of existence. But down here on Earth, if you look up at the sky or watch the waves crash on the beach, nothing looks different. The day carries on exactly as it did a moment ago. That is because our eyes do not process the universe in real time. We only perceive events when the light they emit finally reaches us. Light moves incredibly fast, but it still obeys a strict speed limit. Across the vast emptiness of the solar system, it takes those final rays of sunlight exactly 8 minutes and 20 seconds to cross the gap and hit our planet, which means humanity is currently living in a ghost reality. We are safely basking in the warmth of a star that is already gone. The delay applies to gravity, too. We know this thanks to Albert Einstein's general theory of relativity. His equations demonstrated that gravity is not instantaneous. It ripples outward in mechanical ways that travel at the exact same speed as light. So the orbital track holding us in place is maintained by those final traveling waves. Right now, 8 billion people are going about their commutes, drinking their coffee, and living their lives completely unaware that the physical laws holding their world together are ticking down. For these specific 8 minutes, Earth is suspended entirely by the fading momentum of a dead system, orbiting a space that is completely empty. When that 8-minute and 20-second timer hits zero, the final photons arrive. A bright, sunny landscape is instantly plunged into an absolute ink-black void. Even the moon vanishes from the night sky. It produces no light of its own, so without the sun to bounce rays off its rocky surface, it becomes invisible. Without the sun's massive gravitational anchor pulling inward, the delicate balance of orbital mechanics instantly breaks down. Instead of traveling in a circle, Earth's forward momentum takes over. The planet begins moving in a straight line, tangential to its former orbit, shooting outward at 67,000 miles per hour. The moment the light dies, Earth transforms from a stable, life-giving planet into a rogue, untethered spaceship hurtling blindly into deep space. Without the constant influx of solar radiation, global temperatures drop rapidly. Within the first week of darkness, the surface plunges below 0 degrees Fahrenheit. This infographic shows how plants convert carbon dioxide and water into food. Look at the solar energy inputs required. Without the sun, photosynthesis halts completely. The base of the global food chain collapses, permanently depriving the ecosystem of glucose and guaranteeing mass extinction. Fast forward exactly 1 year, global temperatures hit -100 degrees Fahrenheit, causing the surface of the oceans to freeze solid, but wetter is highly unusual. When it freezes, the floating ice forms a thick planetary thermal blanket over the liquid below. While the surface becomes an apocalyptic wasteland, that sheet of ice effectively shields the deep oceans. It insulates the water underneath, preventing the depths from freezing solid for hundreds of thousands of years. Thousands of years into the future, the Earth cools to a -400-degree frozen rock, causing the atmosphere to collapse entirely. Yet miles beneath the frozen crust, vibrant ecosystems still thrive. They gather around extremely hot hydrothermal vents, where boiling water erupts from the floor. These organisms rely on a process called chemosynthesis. Instead of catching sunlight, they process the raw, toxic chemicals seeping directly from the Earth's crust. Specialized, bizarre creatures like pale fish, crabs, and massive clusters of white and red tubeworms form an entirely independent food web down here. Because they are completely insulated by water and ice, these bottom-dwelling ecosystems would survive indefinitely. They would carry on, entirely unaware that the sun ever died. As for humanity, the question is whether modern civilization possesses any viable path to outlive a rogue planet scenario. Survival would require abandoning the frozen surface. We would have to look downward, harnessing the massive reserves of geothermal energy radiating from the Earth's core. Pockets of humans could potentially sustain themselves inside heavily insulated underground bunkers or aboard deep-sea nuclear submarines, drawing power and heat from their own reactors. The sun drives almost every natural system on our world, but the Earth possesses its own hidden internal batteries, capable of keeping a fragile spark of life going even as we drift into the darkest, coldest corners of the cosmos.